Testing, testing. I believe that's all right. Okay, welcome to Programming Rainbow. In this video, we will start a new project called Don't Eat the Yellow Snow. This one's in SDL3 and this is in C. Okay. You can go to github.com, Programming Rainbow, and this will be called Yellow Snow C SDL3. Now, I want to show you two different projects first, or I want to show you this project, the final. So, I'm just going to use a make file here, make clean, release run, and I'm going to pause the music. And this is me playing the snowman, and I can collect the white flakes, but I don't want the yellow flakes because they might be peat. Okay, so this is the game, and I've done this before about a year ago in SDL2 and C. I've since cleaned up the code a lot, but this isn't the actual where we're going with this. So this project is going to build what you're seeing right here, but what I really want to get to is this one right here, which is the neural network playing Don't Eat the Yellow Snow. So this is still the SDL2 one that I'm going to show you, but that's just because I'm still breaking up the code into how I'm going to do it. But basically this series is going to make the game. The next series after this series is going to take that game and add on a neural network to it and let it train the network, let it run off the network, and it's going to be having different parameters passed in from the command line. It's going to be multi-threaded, and this is what that looks like. And on this one, I'm sorry, but I can't mute the audio because I didn't add that feature in, but it will be, since we're working on the project, we will be adding that feature in. So just showing you where it's coming from right now. This project, I'm just going to run it yellow snow. I'm going to tell it I want the AI turned on, and I'm going to tell it to use this file right here that has a pre-trained model already in it that I trained up, which that file is right here. It says it's 22 megabytes. It's actually because I have made this model where you can have, like, I think something like 60, that like your hidden layer size can be 64 or larger, I can't remember, and 10 layers deep. Even though I'm only actually using one layer that's 15, size of 15, one hidden layer, I actually allocate all that space so that you can, like, choose what you want to do with it. But anyway, let's see it running. Now this is running itself, and like I said, I can't mute the music on this one, unfortunately. And it is pretty smart, but it's not superhuman smart. You know, this is probably not perfect, but it's good enough to see how a neural network runs. And you see it just lost there at 23. It got 23 points. It gets around like 30 points. Sometimes it ends quicker. Sometimes it, gets up to like 60. And it's enough to show how this model works and how everything, but you can play around with it, or it could be optimized later, maybe more, but you get the idea. It's playing itself. It's got a little neural network inside of it that's been trained up, and it's playing itself. So that will be the series after this series. We're going to make the game first, and then we're going to turn the game into its own little AI, to just see how a simple neural network works. I just wanted to see it without any kind of hidden libraries or any of that. So when we make that second project, we won't be using any hidden libraries. It'll just be structs, and it'll just be written straight up in C. Okay, so first things first is we're going to build this project. This one is going to be all boilerplate. At the end of this video, we're going to be opening and closing a window, and I'm going to try to go through it as quick as possible because it is boilerplate. I have a series already explaining the beginner's guide, so I'm going to try to move through quickly. So, okay, let's just look at some of the functions we're going to need. So we're going to need to initialize SDL, and we have some flags down here, and these can be ORed together with a binary OR operator, which is a single pipe. For this video, please go on by. For this video, I'm going to use SDL init as SDL init video. Later on, we're going to need audio too, but I think actually I forgot to turn the audio on, but it still works. So We may OR those together later. We don't need events, even though we are using it, because the video will automatically bring in events. So this is the flag I'm going to use. So we're going to use this function with that flag right there. And the type of this is SDL init flag. In SDL2, I think it was just like an int or something. But this time it is actually a type. And then we are going to quit SDL. And for people on Mac, somebody let me know that if you just open a window, but you don't actually queue events, the window will never show because Mac will think that it's a background process or something like that. So we're going to do it in a little bit different order. I'm going to kick those events in first, so people on Mac will be able to follow along just fine. Also in here, I am using Clang D. If you're using Clang D, you will, if you're on Mac, we have this because you're probably installed SDL3 through Homebrew. So that should sort you out there. I have some instructions for Arch Linux on the GitHub page right here. Our SDL3 itself is just part of the standard, package that you can install. However, I haven't checked them today, but I'm sure they're still in the AUR, and you're going to need the SDL3 image, the SDL3 TTF, and the SDL3 mixer. So you do need 4 different packages for this project. So if you're on Mac using Brew, you'll not just need SDL3, but you'll need those other packages, the SDL3 image, TTF, and mixer as well. And just to make sure that we know your system has those packages, let's just use something from this makefile real quick. You're going to need package config and SDL on your system to build it. So let's just run this file, this command down here. This is package config -- libs, and then SDL3, SDL3 image, SDL3 TTF, and SDL3 mixer. I don't think there's supposed to be a comma here. I'm just going to run it first, and then I'm going to fix that. There we go. And it looks like no issue. I'm just going to remove this comma. So it looks like the comma wasn't causing a problem, but I don't like it, so I'm going to remove it. Okay, so your system, hopefully, if you have those packages installed, should say something like this. If you don't have package config or you don't see this at the end, you probably will need to sort that out before going any further. Okay, so that's enough of that. Let's start coding. We're just going to use this makefile. I'm going to explain it probably in a later video. This specific command is for Mac people, and this just tells if you're using Clang D as your LSP, where the include for, so it doesn't complain about function names from SDL3. If you're on Linux, it should already figure it out on its own. If you're on Windows, I don't know, man. Maybe not use Windows. Okay, so I have the final project here. We've already seen it. I'm just going to go ahead and delete this folder. And I'm going to recreate it. Okay, so we have this empty folder. And we're going to need a couple files over here. So I'm going to go back to where this folder is. And I'm going to create main.c, main.h, game.c, and game.h. And I think I call it init SDL. init underscore SDL C and an init SDL.h. Sure nobody's asking questions, and we're still good. Okay. So I'm gonna set this up in the idea of using structs and functions, kind of like this semi-object oriented way that you do it in C. So I'm just gonna break right into that right away. Game is going to be a calloc instance on the heap, so I'm just gonna start doing these things. There's another police going by. So I'm going to go into game H first. And we need to, pound define or put our include guards on. So this will be if and def game h, define game h, and then an end if. Okay. And on all of these, we're going to pull in main.h. That's where I'm going to keep things that are kind of global constants and things like that. So for game, we're going to have a struct. We're going to be holding the pointer to the window, the pointer to the render, the event, and the bool. So I'm just going to build this up one at a time, the most basic thing, and add to it, okay? So the very first thing, like I said, for the people on Mac OS, because we need the event to happen for the window to even show, I'm going to start there. So that will be fine for everybody else as well. So I'm going to, so we did see that we need these two functions. And then we can use delay to pause the program so it doesn't close immediately before we even do a game loop, but we'll also use it in the game loop. And then we need the events. Like I said, if we start checking events, then on Mac and everything else, we can see if we want to close the window or not. And so this is the thing that we're going to hold on to first, is just an event itself. Yeah, so I'm going to come back to this. We first need to, so I'm kind of scattered on what to actually create here. So I think I'm going to jump from this and go into instead. So I'm going to come back to this. Sorry about that. I'm figuring out which way to do it in C. We're going to come right back to this game in a bit. But first, the very first thing we need to do is initialize SDL and close SDL down. So I'm going to do it here. I'm going to create my game init SDL here. I'm not putting it in game, even though I consider it part of game, because I don't want game to become too large. So this is kind of it. Most things I put into their own modules, but since I don't want game to keep growing and growing and growing, I'm going to put this. This is kind of a helper function, that would normally be in game. So it's associated in my head with game. Okay. As in, game holds a game struct and all the functions that deal with game. And this init SDL is also going to hold a function that deals with game, but if I put it in game, it'll end up making the file too long, and I don't like that. So it's just I'm separating this one function out. So I'm going to call it the include for this is init SDL.h, and this is going to initialize SDL for us, and it can fail. So I'm going to return a bool. I'm going to call it game init SDL. So I call everything that's associated with game, and if it's like associated with player, I call it player. So this is, like I said, I feel like it's associated with game, and it's going to pull in the game struct that we're not going to need it just yet, so I'm not going to put it just now, but it will be, because I'm kind of just trying to initialize SDL first. So when we initialize SDL, if it fails, it's going to return false. And if it succeeds, it's going to return true. That's in SDL3. And we're going to use this one flag that is down here. It is SDL init video. We're going to use this flag right here. And it's this type right here, but I'm going to hold it in a pound defined. That's what I'm going to do. So it's going to be if bang, because it could fail. And what I'm going to put in here is I'm going to make my own pound define that is just called SDL flags. And then in there, I can put however many amount of flags, and it'll just be the same. So I'm going to put this pound define in main.h, but this is where I'm calling it. So this is just something I'm creating myself. There's nothing called SDL flags. I'm just creating that one myself. And it doesn't exist yet. So if I did this, it's going to error. So if this function fails, I want to print it to standard error. So I'm going to use fprintf. That's just file printf formatted, or file print formatted, or formatted print file. I'm not sure which one, something like that. And the file, we want to send it to a standard error. So std error, that's the first one. And here's the string. Error initializing SDL3. And we'll get the error string from SDL get error. So we'll put a string here. And I'm not going to put a period on that because I don't know what the string is returning. But I'll just do this right here. And the function to get, I did open it up, but it's just literally this function. It's get error. And this is going to return whatever internal SDL error was created. This is going to return that string. So it's going to print this out. And right here, it's going to be whatever this returned, which is the error message itself. And then I'm going to return false out of here. So this false is going to be returned on this bool here. This function failed. And since this is returning a bool, the happy path is going to be true for us. And I'm not setting the window yet or the render yet. So this is going to be enough for this. It's going to complain. So what I need to do, we don't even know what SDL is here, and this is also not defined. So I do apologize. I'm bootstrapping everything right now. I'm doing it a little bit out of order. I should have been in this file first. But main.h is going to have us bringing in SDL3 and defining. So I'm going to put my include guards if def main.h. Okay. Now we need to bring in SDL3 so that we can use that function. That's part of the reason why I was complaining. So the SDL3 is just going to be SDL3 SDL.h. Sorry, this is angle brackets because this is looking for it on the system, not locally. Okay, so that will give us access to SDL functions. And I'm using bool and C, so I'm going to bring in standard bool. And I'm also using IO because of printf. And I'm using standard lib for several different things. One of them is going to be the exit, and the other one is, I believe, the calc is from there as well. So these are what we're going to be using for this video. And also I want to define what that SDL flags was, which is going to be the SDL init video. So remember I said I created that SDL flags. So we're defining it now. And the only thing I really need right now is that SDL init video. I'll let the police go by. But later on, if I wanted to add something else, I could put a single pipe here and I could do SDL init audio or something like that. And I can't remember off the top of my head if we need to put parentheses around this. We may need to put parentheses. I can't remember. But we don't need it right now. That's going to be everything we need right here. And that should stop the errors that we were getting in, where is it? In here. So we're including init SDL.h. And in init SDL.h, we should be including main. So if and def. So this is init SDL. Okay, and then the end if. That's just the include guards. So on all of these headers, I'm bringing in main. That's why it's complaining it didn't have access to what we just did in main, but now it will. Main.h. This is local files, so this is in quotations, double quotations. So now finally, this is no more errors here. So now it, because we're including H over here is including main, and main has SDL3, and it also has this defined right here. So that's all good now. Trying to figure out what order to do all this in. Right. We need the events. No matter what, we need the events. So normally I would make a window or even something else and then just, like have it pause for 5 seconds. But the whole thing is it does not work it doesn't work in Mac unless we are pulling events. So we got to go to events. Oh, let's since we've initialized SDL, let's do the proper thing and close it down. So I'm going to make we're going to be making a game new where we create a game struct on the heap, and then there'll be a game free where we release all the resources and shut SDL down. So I need to make the game free right now. I don't have anything on the new yet. So this is kind of like set up out of order, but game free. And normally this would be taking a pointer to the game struct, but we don't have that yet. So the one thing that we really need to do is the SDL quit, because we brought SDL online. So that definitely needs to be in here. And I'm just going to put a little print F here and put all clean. New line character. Yeah. So game H should have, oh, okay, it's complaining about this right now. Where's game again? And now game's not complaining. Okay, so that was us kind of initializing SDL and then bringing it offline. So let's go into this. This would be done, the initialization would be done in game. So I'm going to go up here. This can fail, so it'll be a bool game new. I'm trying to get us to the minimum that we can just launch this real quick. And we don't need to calc anything yet, but we do need to run that function game init SDL to get SDL online. So if game init SDL, and it's going to complain because we need to bring that in here. Like I said, this is like extending game, basically. Extending adding another function onto here. So we have SDL, and we don't have any parameters yet to pass in. And we're going to return false. Otherwise, we're returning true. Wait, what for what? Okay, so this function that we created in here, I need to put it in the header file. So that it can be seen in game. And some of these will probably complain because they're void. So where are we? Okay, so we have game new, game free. It's not doing anything, that's fine. We have main. Okay. Yeah, I'm a bit like I'm trying to bootstrap this, and this is all boilerplate, and I'm trying to think what's the minimum thing that I can write in what order to just launch something. So it's I should have thought about this a little bit. I know the end product of what I'm having in this video, but how to get to the minimum launchable state is causing me to scratch my head a little bit. Okay, so in here, let's get it where we can launch something. Include main.h. This is where our main function is. Int main, and we're not passing anything in here, so it's just void. And I'm going to have an exit status on this one, so I'm just going to create it first, bool exit status, and it's going to be set to false. If it ever gets to the happy path, we'll flip it to the success. Otherwise, it's going to just be false or a failure. And this is from SDL.lib, I think. Yeah, SDL.lib. It just added it up there, my LSP, but it doesn't need to be there. And what I really just need to do is call game new. And I'm not going to put the bang on this one because I'm looking for the happy path, not the failure path. So if this function succeeds, and what I need here is game 8. So if this succeeds, I'm going to set this exit status to success. So I'm looking for the good path, not that. That's why there's no bang on the front of this one. I'm looking for if it's successful. Exit success. All right. And then I'm just going to call game free. And game free is a void. It doesn't return anything, so I don't need to wrap it in any if statement. That's going to, so what this is going to do, game new is going to bring SDL online. Game free is going to bring SDL offline. And then I'm just going to return the exit status. So if it got switched to success, it's good. If it didn't, if this fails, it's not going to be successful. Okay. So these game functions need to be in their header file. These two right here. So I'm just going to yank them and put them in here. And delete this. I'm pretty sure it's going to complain that I didn't put void in there, so I'm just going to check a void in there because I'm using a makefile that's a bit strict. And let's go back up into game and change this as well. This one. All these are going to have parameters. They just don't right now. So main is going to call game, and if this is successful, it's going to set it to success, and then it's going to clean up and exit. So this should just launch and then close successfully. So a game already includes main, so I'm gonna just remove this one right here. We don't need it since the game H already includes main H. So I'm gonna hope that I didn't make any mistakes. And if I just call make, and I don't even need release, but I will, well, let's do debug. So if I don't tell it what source directory, it's going to automatically do whatever's in src, which is everything we just did. Okay. So, and it says all clean. And then it tells me I have memory leaks. Now, this is probably just because I started it up and closed it down too quickly, not because I don't think there's any actual issue happening right here. I think it's just because I literally launched it and closed it immediately. And it just, says I haven't cleaned it up. Yeah, this goes on for days. Come on now. I kind of want to ignore this because I don't think there is a problem. SDL4, this is where we are bringing SDL online. Yeah, I don't think there's any issue happening right here. So I'm going to kind of ignore that for right now. And that's only if you run the debug. Okay, so that doesn't really do anything. It didn't really open anything. We have to kind of deal with the fact that we need that brings SDL online and it quits SDL. But we need to deal with events. So we could delay, but it won't do anything for us right now, the delay. That would just pause it. What we really need to do is pull events. And this deals with events. So when we have our game, when we create a window and open it and everything else, if we're moving things around, those are events. If the mouse is moving, mouse is clicking. If we want to close it, that's an event. All those things are events. So the most important event right now would be to close the window. If we're going to open a window, if we have no way to close it, if you try to click on the check mark or the whatever the way you close it in whatever operating system you have, if we haven't set up events, it will not close. Like it's a C program. You have to tell it what to do. So the window manager could say that you want to close this, but it won't actually close unless we pull those events that we check the queue of events and see if one of them was a close or a quit event. So this is the function that pulls the events. And this is kind of what it looks like, what a simple game loop would look like while the game is running. And they're creating this instance of the event right here. And then they are sending that in, the address of that in, and populating it with this pull event function. And this pull event, it's running a while loop. Every time this function gets called, if there is an event if this event did get populated, it returns a true or a 1. I believe it's a true. Returns true. Okay, so yeah, if it was populated, it returns a true. So that runs this while loop. Okay, so anytime when there is no more events, this isn't going to be populated with anything, and this will fall through. This won't be true anymore. Okay, so that's kind of how it works. This pull event is going to populate this event. The event itself is a union, and it could be lots of different things. It could be a key press. It could be a quit event. It could be lots of different things. But the thing that we want to know about is it a quit event? So if we look down here, these are the possible events it could be by type. And there is one called SDL event quit right here. And that's the one that we're going to look for. Yes, but specifically in SDL3, it is a true. It's a Boolean. But yes, you're right. And C, anything that's not 0 is true. So like not only is like 1 true, like any number is true, but even a negative number could be true if you put it in an if statement. So in SDL2, it was different. I think SDL2 put a 1. And so I know in C under the hood, the Boolean is 0 and 1. That is true. But they specifically are using the Boolean type true for this one. Okay, so we are looking for the SDL quit event. And let me get back to my notes. So what I basically want to do is set up this event first so that it can work in everybody's system. So this is going to be in game. And we do need to create this. We're going to calc this new now. So that we're going to move to that. So I'm going to go into game H first. I'm going to finish this struct. This is going to contain the pointer to the window and the render and images and things like that. But just to get the ball rolling, we're going to do the type here, which is this. Where is it? This is it's just a SDL event type. Clicking on the wrong thing. There we go. That's the type. It's a SDL event. So I'm going to put it here. I know they did it differently. I just think that you don't need to recreate the whole. I don't need to recreate it over and over again. I can just use the one I've already created, but you can do it either way. So I'm going to put it here. I'm just going to call it event. And it's not a pointer or anything. It's just a union. We're going to put this here. But now we can have this whole thing where we have this struct. So new and free now are going to look different. So this is going to be struct game, and I'm going to put a pointer to game. That's because I'm going to pass in the pointer to game and calc it. So I do need the pointer to pointer. This was explained in the beginner's guide. And I'm also going to do it with the free because I want to affect the pointer itself. I not just what it's pointed to, but the pointer itself. In this one, we need to actually allocate memory to the pointer itself, or return the pointer that has the memory. And this one, we need to set that pointer back to null so we don't have a dangling pointer. So what I want is a pointer to game struct, but I'm sending in the address of it so that I can affect it. So we're going to go into game. So there we go. And this one down here is going to look the same. And I usually do pointer G is but when I do double pointers, I write in the whole name explicitly. That's just my style. So the first thing we want to do is actually allocate memory to this. So I'm going to read dereference game one time. And I'm going to calc it. I just need one of them, and it's going to be size of struct game. Okay, so what happens is if I were to do this right here and this wouldn't work. This would allocate the memory, yes, and this would be a pointer, yes, that would be. But this would not change the one I passed in. It wouldn't change the one outside of this function. So I do need, this double pointer, the address of the pointer, and to dereference it. So I need to do that to make it work. Otherwise, it's only happening inside the function. Now I'm going to check it. Make sure it's not null. If calc fails, it returns null. So if this did return, it failed. So we're doing the f print to f, and this is going to standard error. And I'll say error in calc of new game. And that should be it. There's no SDL get error on this one because the error happened with the calc here. And we'll return false. Okay, so that gets us up and running with the now we have it instance, and we're using Calyx so that we don't have any uninitialized data. Now I don't want to keep dereferencing game, so I'm going to go ahead and make a local pointer. So now I can go ahead and use game instead of dereferencing over and over again. I can just use G to do what I want to do. And I am going to be passing G in here, but not yet. Okay, so I'm going to add is running to this. It's going to be a bool because we're making a little game loop. So back in here, I'm going to set that is running to true. It'll be false by default because of this calloc again. So I'm setting that to true, and that's going to be that function now. Now that we have this on the heap, this needs to take care of that. So the first thing we want to do is this could fail out, and this could not even be allocated. So we need to make sure first that game has actually been allocated. So we're going to check if game is actually allocated. And I'm going to put that whole thing in here. Yeah. If it's a simple loop, I just use I, J, K. Or if it's rows and columns, R and C. It depends on like how, I try to keep it simple, but also like to tell it what the thing is. And for function names and stuff like that, I give it the name of whatever C file it's in, because it's kind of like, I think of it as a module. So if this is, let's see. So this is gonna look silly now, but later on I'm gonna use the G more often, so I'm gonna dereference this again. Even though it gives me nothing right now, later on it will be. So that, and what we need to do is basically after we've brought SDL offline, we need to clean up the memory that was allocated to game. So I'm gonna free G. And then I'm going to set G to null, which is just local, so it's not really doing anything. But now to affect the real game pointer that is somewhere else, I am going to set that to null. Like I said, this may seem like too much right now, but there'll be more stuff in here. I'll be using G more times in here, so right now there's just really nothing going on here. Yeah, it'll make more sense as it grows. Oh well, this project is making the yellow snow in SDL. So I have lots of different projects. If you look through, I have Conway's Game of Life, Minesweeper. I haven't finished setting it up, but I'm gonna have Tetris, stuff like that. So for these smaller, so you're asking me if I have a global state. So the only global state, like I don't have any global state. The right here is my global constants. Main H is my global constant. So these are constants. These are not changing. They're not variables. There's no global state happening here. But there is a game state. And the game state is happening here. And because this is a small project, I am going to be loading the images and stuff in here. Also because the way it's going to be done, and even done later on, I don't want the same image loaded 15 times. So I'm going to load it one time and let the 15 instances of it have a pointer to that image. So it's not a global state. This is a game state. But depending on how big your game is and stuff like that, you can like you'll see the player, we could load the player image with the player struct. But in this specific game, I'm just loading it all into game because it's only 3 images and 3 sounds. So since it's so small in scope, I just keep it all in game and give them the references. But if it was a larger game, I would localize it, like if I had a player struct, then it would just have the stuff for the player, but the player would be a member of game. But for this instance, yeah, I am putting the sound effects and the images in the game struct, even though I will have structs for flakes and player, and they will be holding pointers to things. But they're going to be a bit modular, yes. But since it's small in scope, there isn't a reason to go too crazy with it. Okay, so where was I? Is running. So I set is running to true. What I really want to get to is making this whole event. So I'm going to make this game loop down here and then make the event that is going to break us out of the game loop. So the game loop right now is just void. I'm going to call it run. So it's just going to be G as a pointer. And that's how I'm going to do everything, as long as it's not a double pointer. And just like what we saw, where was it, in the poll event, this game loop right here is what I'm going to do. This is my game loop and this is my event loop. So I'm going to basically make it similar to that. So here's the game part of the loop. While, and I have that is running. Whoops. So while is running, it's just going to loop infinitely. And now we want the events, basically. So I need another function up here. And this one is void as well. I'm going to call it game events. And this one is going to do the while SDL pull event. Remember, SDL pull event will return a true if it does have an event on the queue. So you could have 10 events, like you moved your mouse X, you moved your mouse Y, you clicked, you pressed the T key, the 2 key, something like that, right? It's going to go through all those, and then each one of those are an event, and then they're going to be empty, and then after that's empty, your game keeps going, and whatever keys you pressed until the next time it goes through this while loop again will be the new events on there. So we're going through it's popping these events off and giving them to them one at a time. So there's a queue of events, and it's going through that queue and giving us one event at a time. And we're looking for the quit event, basically. Pull event, yes. And we need to send in the address of this event. So this event is G event, right? And so we need the address of that because it's going to populate it for us. And now we can switch on this event. And the very first thing we need to know, since this is a union, these events are unions. Let's look at the event itself right here. This event is a union. So the very first thing when you're dealing with a union is to check the type, because it's going to be one of those types and we don't know. But the types are down here, and the type that we're looking for is if it's a quit event type. If it's a quit event type, we don't really care about anything else that's going on. We just know that this program should be shutting down now. So I don't need to ask any more questions. If it's a quit event, that's enough information for me. I'm going to quit. So I'm going to switch on this, on the event. G event. And the case we're looking for is SDL event quit. So in SDL2 is called SDL quit, I think, but in 3 it's called SDL event quit. And if we do get that, basically I'm just going to change the running to false. So is running is going to be equal to false, and I'm going to break out of here just because you always should do that. And I'm also going to create a default case because my compiler is a little bit stricter and it will complain. And that's just going to be a break as well. What did I do with this switch here? I messed something up. Oh, it's dot type. We're checking the type of this event. Okay, so we have this event. So what I'm going to do down here is I'm going to call this. It's events. And we're going to pass G into it. And I also just don't want it running at breakneck speed. So I'm going to tell it to pause. And I think 60 FPS is a good starting point. So what I'm going to do is, just as a very cheap way, is I'm just going to tell it to pause for 16 milliseconds, which is roughly, it's not exactly, it's 16.666, but there's also the time it takes for code to run. But we will do delta time later on in the final video. Right now, this is just going to be good enough to run it at about 60 times a second. Otherwise, we're just going to run the CPU up. So we have this this delay right here. This just releases, it gives control back to the system, so the system can do something else, and then it comes back in whatever amount of milliseconds that you want. And like I said, 16 is going to be good enough for us, and this is just going to be fine. It's just a void function. We put in 16 and we're good to go. So we have a little game loop going on right here, and it's calling event, and I'm going to forward declare these functions, or at least the event one. Event, I need to forward declare it at the top. Okay, so we don't need this. This is already it's already brought in main and SDL. It's my LSP automatically adding in. So this is needs to be in the header, this needs to be in the header, and this one right here needs to be in the header. Okay, so main. Okay, so we're going to have to deal with this now. We have we need basically to instance this. Remember, it's supposed to be on the heap. So what I'm going to do is I'm just going to create a pointer in the local main, right? So I'm not calling it G here. I call it G when it's inside of the game. Like we're inside of the main C right now. If I was inside of game C and I'm calling a bunch of functions, I'm just going to say G because I know I'm in game. G is game, right? But I'm in main. So if I had some functions in main, maybe I'd just say M or something, but I don't. I don't have a main module. I don't have a struct named main. So I'm calling it explicitly game here. And I'm setting it to null. Okay, so that is null. And now we need to pass in the address of this. Because remember, new takes a address to a pointer. So game is a pointer now. And we're sending in the address of the pointer. That means it can populate. Now this pointer is no longer null. And same thing down here. We need to put in the address to game. And now if we were to check this pointer after free, we'll see that it's null again. It should have an address here. If it is null, even here, this will checks to see if it's null before it tries to clean up. But if it isn't null, if it is something, it's going to clean it up and set it to null. And that's what we did in game. See in right here, the first thing we're doing is checking to see if there is associated memory to it. And then we're setting it to null. That sets the real one. That's why we're sending the pointer to the pointer. And the same thing with the new, the pointer to the pointer, that's so we can affect the one outside of it. So that's what's going on here. And right here, we have this new, but let's do a run now. And we're looking for the happy path on this one because we're assuming bad things. We've set it to failure. And if it gets to the happy path, so that's why there's no bang on this one. This is as well. I'm going to do if this is happy, I'm going to do game run. And this is just going to be game here. It's not a pointer to a pointer. And if this is still happy, then we set it to success. And sorry, this is void. We're not checking that. Later on, we will be in a different video. In this video, we're not. So I forgot that. Sorry. Okay, so still, this one can't fail right now, basically. Yeah, so we should be able to run this, and we should have, basically, it'll be running. It's not going to open anything up, but it's not going to end the program until we need, it won't stop running because we can't tell it to close. Well, let's find out. I may have to close my terminal if this doesn't work. I didn't check this ahead of time. Okay, so right now it's running. It hasn't returned me back my, it's got control of my terminal. And if I were to tell it to quit, oh, it did say all clean. So it did quit. Let's check it again. It creates a binary called yellow snow. And see? Yeah. And it's still complaining about memory. I am a little bit worried about that it's still doing it. We are shutting it down, though. I am shutting it down. SDL quit. It's right there. Yeah. Well, we haven't allocated. Yeah, we're not cleaning up. We haven't created a window in a. That's a long story about what. So you. So it's so I kind of want, like, I used to run my own Linux distro a long time ago, and I didn't know it was hard. I didn't know it wasn't an abnormal thing to do. So I started using Linux, and I started using like Slackware. I tried a bunch of there was like Mandrake at the time. It turned into Mandriva. I don't think it exists anymore. There was SUSE. Like, they used to be in the magazines a long time ago, in the was it the early 2000s, the late 90s, early 2000s. And I started using what is it, Slackware. And Slackware is just like, it doesn't give you anything. It doesn't have anything. And I played around with it a little bit, and then I played around with Linux from scratch. And I ended up making my own Linux distro, and I created my own package manager, and then I created my own syncing and everything else. And I didn't know anything about programming, and I didn't know anything about Linux. And so I used to have my own Linux distro for a while, and then I just stopped. And I think I don't know if my computer broke. And then later on, I had a MacBook, and I just kind of played guitar a little bit, and I forgot about computers. And the MacBook broke like years after that, so I hadn't done anything for years. I did Linux like hardcore more, like for years, and I had my own Linux distro called Maya OS. This is a long time ago, and I didn't realize there wasn't other Linux distros out there. There, like every Linux distro out there right now is either Red Hat or Debian. Like, that's every Linux distro is either Red Hat or Debian or Arch. I don't know if there's any others that are not those, or Gentoo. That's everything. So mine wasn't any of those. Mine was just completely, like, I built Linux from scratch and then turned that into a distro. And I had, like, I don't know, 5, 6, 7 different desktops set up. I mainly was using KDE, GNOME, XFC, and OpenBox and stuff like that. But I didn't know it wasn't normal. I was just in my own world. But I always thought that you couldn't learn programming. And then my son, years later, like 10 years later, was at school playing with Scratch. And I was like, oh, that's, yeah, the variables and stuff. Yeah. And I started playing with that. And I was like, well, this is nice, but we need to move on. And so I tried to get into Python, and I realized Python is a buggy mess. And the documentation and the books were just broken books, terrible books. It didn't work, and there was bugs all over the place, and it was really frustrating. And then when I looked any further, I wanted to go down from Python. I was using Pygame 0, which is just awful. And then I switched over to Pygame, which was better. Pygame was better, and it made more sense, and it worked better. Pygame 0 basically is a not good thing. And then I was like, well, I want to go to C. So C was much harder to learn, but I had much less problems with it because when something was going wrong, it was because it was my fault. In Pygame 0, when something was going wrong, it was because I didn't understand it, and also Pygame 0 was broken and built on a house of broken cards. And when I tried to do something in C, it works unless I'm doing something wrong. And also, there was almost no documentation for C and SDL2. There was just nothing that existed, which is why I made this channel. I just got frustrated, and I tried and tried and tried until I finally figured it out. And, so that's where we ended up now. So basically, I thought I could never do this, and I always wanted to, and I never tried. And then finally, I just started trying. Yeah. Yeah, Python's terrible because Python is built on a whole bunch of modules, and all those modules are going to be broken. And it's just a terrible experience, especially for kids or newcomers. If you don't know if it's your code is the problem or Python is the problem, and it's pretty much Python is the problem. And I don't think Love 2D was out so I sat there going through these books from the library with my son, and the books were wrong, and the books were broken, and it was bugging, it didn't work, and it's so frustrating. And so, yeah, if you watch I have a Python videos, and I think I rant about Python a little bit in those videos, but I haven't really touched Python since. I really don't like Python. I think it's not good. It's not a good programming language. It is easy, but also it doesn't matter how easy it is if it's broken, and it is broken. It's just broken all the time. So I like Lua, C, Lua, Go, what else? Odin. I haven't tried Zig yet, but these are really good. C++ is like trying to be better, but not better. It's also trying to be worse at the same time. And Haskell is fun, but weird and stuff like that. And I played around with Rust. I played around JavaScript, and JavaScript is like, we made Python worse or something. And JavaScript is like Python and C++ had an awful love child, and it's terrible. I don't know. I hate JavaScript. There's like 15 different ways to write a function or something. I don't like that. Anyway, I'm going to have to go and stop the stream here. I'm going to come back later and finish the stream, or maybe I'll restart it. I'll probably just finish it because I have to actually go I have to get to the school and pick up my son. So I was, what happened? I monitor on my son's laptop here, and he's using LibreWolf, and it was stuck on white theme, and I spent an hour trying to remember how to get dark mode back in LibreWolf, and that stopped my stream. It was like I knew what I was looking for, but I couldn't figure out where to find it, and I was just stuck for a while. So I apologize. I'm going to come back and finish the stream. Yeah, I actually have. So let's see here. So what I did is I started making before I go. See this. So when I was learning, I started making this. I made this yellow snow a long time ago, and this code is much worse. It's like 2 years old. But then I started doing it in different languages. I was like, oh, what's it like in SDL2? What's it like in ArrayLib? What's it like in C++ and Raylib, C++ and SDL2? What's it like in Gforth, which I had to write the bindings for Gforth myself, which I didn't know how to do either. What's it like in Go, Haskell, JavaScript? And if you see my code here, my code's terrible. Like, I didn't know what I was doing, but I kept retrying and redoing it and everything else. So this game is like, there's like 10 versions of this game here. There's Rust, Gosu, Ruby, Pygame 0, Pygame, Lua, JavaScript. But the code that you see on the video is not that code. Like, I've rewritten it many times and rethought about it and stuff like that. The only reason I'm doing it again right now is because I want to do the neural network that we're going to do later on with this. So, and I really wanted to do it in COBOL. I really want to do the neural network in COBOL, but you can't natively do multi-threading in COBOL. So COBOL's off the table, but I have some videos on COBOL, and I really wanted to do COBOL as neural network in COBOL would have been hilarious. It would have just been so funny. But yeah, I do have to leave. Sorry, I have to run. Thanks, guys, for watching. I will try to come back in an hour or two and finish this video, though. So sorry about that. I do need to run, though.